So one day I was playing on a Minecraft server called Stoneworks. We had a town there equipped with an observatory. Together with a guy called Azzar, we constructed this wonderful constellation map of the Minecraft sky by taking a bunch of screenshots and stitching them up together. While doing all of this hard work, it got me thinking, hey, since I'm doing all this astronomy work for a bunch of random pixels in the sky, would it also be possible to scientifically explain the Minecraft day and night cycle? Could I model a planetary system that would explain such behavior of the sun and moon while following the laws of physics? I decided to take the challenge, but trust me, it's easier said than done. First, we need to actually look at the sky and make some observations, and only then come up with an explanation for each single one of them. Let's see what we have. 1. The sun and moon appear to be always on the exact opposites of the sky. When one is rising, the other one is setting. Eclipse does not occur. 2. Day and night last exactly the same amount of time. Both celestial bodies are visible for the same duration of time. 3. The sun and moon don't move in relation to background stars. They seem to be fixed in their position there, all the way through. 4. Both the sun and moon rise exactly on the east and set exactly on the west. Throughout their journey they go through zenith and nadir, so their path on the sky, called ecliptic, looks somehow like this. 5. The moon exhibits 8 phases, each changing each night, providing different light levels. 6. Similar to real life, the sun and moon have a very similar size in the sky. And 7. No matter where we go in the overworld, except extreme depths and heights, all observations above apply the same way. Alright, that is very different from what we can see in the real sky. Oh boy, that is gonna be hard. First of all, for us the sun and the moon travel in the night sky, passing through many constellations, called the zodiac. It is called because we observe the sun at different angles as the earth orbits around it and the moon orbits around us. Because the relative position to each other change, the phases on the moon can occur. We don't have that here, and yet the moon changes its phases. Now, the night and day duration. The only time when you can see 12-hour day and night is at the beginning of the astronomical autumn and spring. See that line of latitude? The more of it is on the light side, the longer the day lasts. Because the Earth is a bit tilted, also known as axial tilt, we only get 2 days in the year when that happens, unless you're on the equator. Their day and night are split equally, just like in Minecraft. Additionally, have you ever seen the sun at zenith? Most of us have not. Because of that tilt I mentioned earlier, it can only take place in this zone. And when it does happen, the shades look like this. Yeah, it low-key looks like somebody lowered the graphic settings. And don't get me started on the place where the sun sets and rises, cause that also occurs twice a year. As you can see, there are a lot of factors we need to take care of, and we'll need to properly explain each and single one of them to create a viable system. Only then we can complete the model. We are gonna be forced to make some approximations, however, that would fit like a regular Minecraft gameplay. So we're gonna focus only and only on the parts we can actually observe. And no, I am not gonna include cubic models of planets and stars, that's just impossible. Let's just put it under stylistical choice of Minecraft, or... there, much better. Let's move on. First of all, we need to assume our Minecraft world is only a part of the planet's surface. Not even one hemisphere, but a single continent at the center. So any effects of a parallax would be small enough to not be noticed with a naked eye. For those who don't know what parallax is, it's when you see an object in a different position because you observe it at slightly different angle. Now, I know the map border of a Minecraft world is about 60 million blocks long, which would make its bigger than Neptune, but let's be real, on your typical Minecraft game you're not going further from your initial spawn than, let's say, 100,000 blocks. Barely anyone does that. Let's play it safe and assume the diameter of the entire continent to be around 350k blocks, which would account for 350 kilometers. Here's Australia for comparison. Pretty small continent we got there, but it's for a reason. We also want to make our patch of land as insignificant as possible, so the size of the real planet will be around the 1.6 size of the Earth. That's how it looks like. That solves problem number 7. Alright, now time for the behavior of the Sun. To fix the problem 4 and 2, with setting and day duration, let's remove the tilt and keep the inclination of both planets and moon's orbit at 0. No more slight imperfections, we keep truly the Copernican model of the solar system. Now the Sun always sets and rises at west and east and takes exactly half time above the horizon as underneath it. Nice! And since our continent is so small, it always will be hovering near the zenith. So good so far. Now, how are we gonna fix the fact it doesn't move across background stars? That's the neat part. We won't. We cannot see those stars during the day, so we would have no way of telling that the Sun moves across them, especially when eclipses are non-existent. Well, that only solves half our problem. What about the Moon? If we want the Moon and Sun not to approach each other and stay on the opposite sides, surely it has to orbit the planet at the same period as the planet orbits the Sun. That would make the Moon move across the background stars. I thought about it for a while and came up with a solution. This is an elliptical orbit. There is no body in the solar system that would move in a perfect circle. Each one of them has a non-zero eccentricity, which tells us how elongated the orbit is. This is a key to solving our issue. Notice how the planet moves around the star. According to Kepler's law, an object on an orbit covers the same area in a given time. That means the planet moves faster when it's closer to the Sun. In real life, we can observe many comets exhibiting such movement. Let's take an orbit of a high eccentricity of 0.8. Here is our planet and the continent, and here is the Moon. Given its size and proximity to our planet, it has to be in an orbit close to circular. Now let's place two moments that interest us the most. One when the Sun is at zenith, and second when the Moon is at zenith. That means during one orbital cycle we need to fit 2 full rotations of our Minecraft world. The planet will be moving slower when it's gonna be far away from the Sun, and hence it's gonna perform most of its rotation here. Mind that the speed of rotation is constant. Our continent is gonna be marked with a small red dot. So the full orbital period is gonna be equivalent to an entire Minecraft day cycle. This part is gonna be responsible for a day, and this one for night. We are gonna be observing our Sun when we are further away from it, which is good, cause it's not gonna change its size enough for us to notice it. The planet rotates to face away from the star as it is approaching it. Let's see how it plays out. Looks good enough. Now let's add our Moon. We just need to make sure it will not be visible during the day and not move much in relation to background stars. So this section is important. Since our planet moves very fast here, the Moon won't be able to move much on its orbit during the night and will mostly stay in one place in relation to background stars. There is a problem though. It will be present in the night sky shorter than we would want to. Let's see how it looks. Well, it looks fairly nice, all things considered. It all narrows down to the eccentricity we choose. When we increase it, the Moon will move less in relation to the background stars, but in return it will be visible shorter. When we pick eccentricity too high, it might cause the Sun to set and rise twice during the one orbital period from our perspective. Not to mention, we might be able to see the Sun and Moon close to each other in the sky and the Moon phases being all messed up. If you choose an orbit that is too circular, then the movement of the Moon in the background will become too apparent and the Sun would rise twice, once again. The key is balance. We need to choose the optimal eccentricity or the whole system falls apart. I conducted some tests and decided to settle on the eccentricity of 0.8. Now, there is always going to be a part of the hemisphere where the Sun rises and sets twice, but fortunately, all we care about is that small portion of the globe. In conclusion, we partially resolved observations 1 and 2, and the only ones left are 5 and 6. But first, I'm gonna use Universe Sandbox to recreate our model. We still need to decide how big the orbit is. Let's have a regular Sun for now. There is no way we can allow the orbit that would take just a few days to complete. The planet would be incinerated with this type of star. Who said that Minecraft Day must correspond to the real one? Sure, one block as 1 meter might make sense, but it doesn't have to be the same case with time. Let's once again observe our surroundings to determine what 1 Minecraft day corresponds to in real life. The typical irrigated wheat takes around 30 minutes to fully grow, that's 1.5 Minecraft days. Wheat in real life takes around 100 to 130 days to grow. That tells us that a full cycle and orbital period is between 67 and 87 days. If we include crops seeded in winter, that takes around 180 to 250 days, and we have to estimate of around 120 to 167 sunsets in real life per Minecraft day. How about other plants? Potatoes and carrots take slightly less time, around 1 Minecraft day, but the real life equivalents also take less time, between 70 to 100 days. And don't get me started on trees. Calculating the estimated average height that emerges from a meter-long sapling would be an unnecessary effort. Oh, and from my calculations, bamboo puts us between 23 days up to 290. That is not helpful at all. Let's look at something much more reliable than pesky plants with their various subspecies and focus on a good old reliable chemistry. Now hear me out, I am not gonna be playing with a Minecraft Education Edition, but instead I'm gonna look at the regular copper. The process of oxidation of a copper block in Minecraft takes around 50 to 80 Minecraft days, while the real copper, depending on the weather conditions and composition, would require between 5 to 30 years. The Statue of Liberty took around 25 to 30 years to turn green, so let's keep those numbers for now. That gives us between 114 to 290 days corresponding to a Minecraft day. Now those are the numbers I can work with. And if you think it's absurd for a Minecraft day to take that long, look at the animals. Most baby mobs takes 20 minutes to grow up, that is 1 full day cycle. Now hold up, but what about the player character? How can they sleep for so long? Is bro just taking a 100-day nap? They hibernate, I guess? Well, how can they stay up for so long then? Well, consider this. Animals that sleep the least include elephants, horses, cows, giraffes, and ants. Now I'm sure you are aware of what absurd weight Steve can carry, and ants are known to be able to carry objects multiple times their weight. But I'm getting out of topic, let's get back to the space. Given the statistics we have, let's assume the orbital period to be around 190 days. We can fix the value a bit later on. Let's apply our orbit and see how big it is. There we go. Now we need to make sure the temperature is right. Ideally, we would prefer to avoid the melting point of steel, as well as an absolute zero. To adjust the most preferable temperature, let's tinker with our star a little bit. Now let's analyze our bright friend here. It appears to have a yellowish color, similar to our star. The color of the star corresponds to its temperature and type. If you look at the HR diagram, the stars with such color, mass and luminosity would be classified as G2. Now, we can assume it's a star similar to our Sun. Hold on. What? Get back to the orbit. Does this system we've created mean that there is one hemisphere that gets exposed each time it comes close to the star? That would mean there is a scorching, inhabitable desert out there. Additionally, the effect of solar winds and the atmosphere there and vast difference in temperature and pressure between both hemispheres would cause massive winds. Well, that is correct description, but thankfully there is no wind in Minecraft. I said there is no environmental wind that we would have to take into consideration. So that's our planet, a lush continent in the middle of one of the hemisphere, which gets hotter as you go away from it, and a deadly desert on the opposite end. Another thing done. Now let's put this thing in motion at the universe sandbox and observe the movement of the sun and the moon. Now that we have our planet and its distance to the sun, let's set the orbit of the moon, making sure it's the similar size of the sun on the sky. That would mean our satellite is around 1.2 million kilometers away, which is roughly 3 times the distance between Earth and the Moon. Oh no. Oh no! With the orbital period we want, it's way too far away. And even if I would make the Moon bigger, it would have an absurd size closing on Neptune. It needs to be at least of a planetary size. We can make the host star slightly smaller, but only a bit before messing up our climate. It's not enough. We cannot put the moon closer because it wouldn't be able to orbit the planet in those 119 days or even 50 days. We also cannot put the moon on a slightly bigger orbit like this because a larger orbit automatically means a bigger orbital period and the whole thing would desynchronize after the first cycle. Let's not give up our hope yet, however, for I have a solution. We need to give the moon the same orbital period as our planet, a different eccentricity. If its orbit is close to circular, we might achieve the desired effect. The problem is that we don't want that body to be too massive, or the whole system would dissipate too quickly. We need to choose a low density for our moon to achieve a bigger radius with the smaller mass. One of the bodies of the smallest density in our solar system is Tethys, with a density of 0.98 gram per cubic centimeter. And that's close to the value I'm gonna apply. Now, our moon can have a higher density, but have large, empty, dark pockets inside. You know, the Endstone had always been portrayed as the moon rock and even acknowledged as such in a Minecraft April Fool's update called Vote Update. So if you're gonna throw the end somewhere, it could be there, just saying. Let's adjust the orbit of the sun and the moon for a better movement on the sky to these settings. Now we land in the specific central spot and we observe. So as we can see, it does not play exactly like in Minecraft, but it's as natural and seamless as it can be. There is a brief period when no moon or sun are visible, and there is a moment when the sun gets closer to the horizon, but not enough to end the night. Sun also doesn't keep a constant speed on the night sky, but that's something you wouldn't notice if you were unaware of it. The moon is a bigger problem, however, as it changes the speed more significantly and actually moves back and forth in relation to the background stars. But it generally stays in the same area, so it's not as much of a problem. It's a compromise we must settle on. Oh, and I should tip the orbit of a moon a little bit, give the inclination just enough so we don't get sun eclipses during the day. Last but not least, the moon phases. It takes 8 Minecraft days for the moon to go through all of them, but we already have a working orbit of the moon which appears always to be full or close to being full. The answer is simple. Our moon's surface. One side of it is much darker than the other one. We have dark basalt plains and brighter highlands on our moon. The one we construct has a whole hemisphere of plains, but taking an even darker tone due to some different composition of rocks. We can observe bodies in our solar system, where two hemispheres vary a lot, like in the case of Iapteus or our moon. Our moon takes 8 orbital periods to rotate fully, sometimes reflecting less light due to the darker surface, and sometimes reflecting more, changing the light level we observe on the surface. Of course, there is still the issue of actual shadows resulting from the star illuminating the moon from different angles, but that effect is not big enough to take into account here, cause the object turns out to be quite small on the sky. Smaller than in the real world and definitely smaller than in the Minecraft counterpart. But I think we can blame this one on graphics, once again. Though the fact we can observe the entire surface of the moon presents yet another problem. Tidal lock we have with our real satellite helps with stabilizing our axial tilt, and we want ours to be equal to 0. Well, we can assume it has that value in the current epoch. Either way, we can only do bare minimum for stabilizing the climate. What about the orbit? Why would it stay like that and not become more circular over time? The gravitational effect would not allow such orbit to exist for such a long time. Well, according to some studies, this issue can be resolved with a second planet in the system. It must be quite far away to not be noticed and quite massive too, like a gas giant. We can also give it a very dark surface color to further explain its elusiveness in the night sky. This relation will cause a precession of our orbit, causing it to slowly rotate across many hundreds of years, so the display of the constellations visible to us would gradually change, but not fast enough to be an issue. At least not in terms of regular gameplay. There is also the possibility of pseudo-synchronisation, which could occur in high eccentricity orbit. The effect would slow down the rotation of the planet when it's close to our star, which could possibly benefit our model by lowering the moon's movement on the background stars. Though the tidal interactions with the star could also mean the circularization of the orbit. And there we have it! Those are the details of the orbits and celestial objects themselves. It's the best I could do to recreate Minecraft sky. Though the system probably would not stay for a very long time in such a setup. I should also mention this thing should have a truly powerful magnetosphere, and the star would be very calm, but as I said, I mainly focus on the movement of the celestial bodies in the night sky, rather than perfect living conditions for villagers. Let me know what you think, maybe you can see some improvements, or a completely different model that would work better. Let me know. That is all for me for now. See ya!